A 5 kilogram object is shot straight up with an initial velocity of 10 meters per second off a cliff that is 40 meters high. If the air resistance is given by 2 absolute V, determine the maximum height of the object. The maximum height the object reaches, okay? So that's the max height here, pretty much. Okay, and I'm assuming downward direction is positive, just the convention. If you want to know, if you want to see the video that assumes upward direction is positive, just there's a link below, look at the comments. Okay, I'm assuming downward is positive in this video. That means going up is negative. So this is mass m, initial velocity, so v 0, so starting here is now going up, so it will be negative for our purpose because we said downward is positive, of a cliff that is 40 meters high. So we can start, that's the initial position, yes, 0 position, yes, that is 0. We can start at 0 so that our calculations look easier. Air resistance is this. Determine the maximum height the object reaches. The maximum height means the velocity becomes 0 momentarily there. Okay, so when we set the velocity 0, we get time, and that's the time it takes to get to the max height. In any case, the force, mass times acceleration, m dv over dt, is weight minus this resistance 2v. And for this direction, we don't have to worry about absolute value, it will be 2v. M is 5. Let's divide both sides by 5, or m. So dv over dt equals, acceleration due to gravity is just 9.8 minus 2 over m, because we divided by m. 2 over 5, that's 0.4 v. Okay, this is separable as well as linear. I want to make it linear. Bring this to the left side. So dv over dt plus 0.4 v equals 9.8. So linear. So integrating factor will be then e raised to integral of this number, which is 0.4. Okay. Is a constant dt, is just a constant t, 0.4 t. Okay, that's the integrating factor. Now we multiply both sides of this differential equation by this integrating factor. We get left side automatically derivative of dependent variable times integrating factor equals, in the right side we multiply 9.8 by e raised to 0.4 t. Next, we want to integrate both sides with respect to t. So this is just v times e raised to 0.4 t equals, when we integrate exponential function, so when we have e raised to some number t, the antiderivative is itself divided by alpha. That means 9.8, this one divided by 0.4, and when we divide 9.8 by 0.4, it comes out to be 24.5 e raised to 0.4 t plus constant of integration. Now divide by this integrating factor, so we get v equals, so that v is a function of time t, in fact vt, divide by this, so that's the 24.5 plus c over this, or c e raised to negative, when I divide means move up, negative 0.4 t. Now we use the initial velocity to determine the value of c. Note that the ball was shot vertically up. This is just the path, okay? It was shot vertically up. With v0, the initial velocity is 10. So using v0 equals 10, negative 10 rather, negative 10 equals 24.5 plus c times e raised to 0. I mean 0 times number is 0, e raised to 0 is 1. Just c. Subtract 24.5 from both sides, then we get c. So c equals a negative 34.5. So we have the velocity function at any time t. This v as a function of t equals 24.5 plus c happens to be now negative 34.5 e raised to negative 0.4 t. Okay, that's the velocity function. So let's put that as equation 1. Now we integrate this velocity to find the position, because velocity is just the derivative of height or position function. So integrate this. If we integrate, then we get position. Okay, we denote that by s. So integrate. See the constant, so and that derivative is simply constant t, and like using this rule again, this exponential, we divide by negative 0.4, so this becomes plus 86.25. when we divide this by 0.4, this becomes this e raised to negative 0.4 t plus some constant of integration, let's say d. Now we are taking that initial height is 0, okay, which is 40 meters up, but we can make it 0. So to determine the value of c, using s0 equals 0, so this is height 0, 24.5 times 0 is 0, plus 86.25 e raised to 0, because 0 times this one is 0, so 1 plus d. So in fact d equals, subtract this from both sides, 86.25. Okay, thus we got the position function. St equals 24.5 t plus 86.25 e raised to negative 0.4 t plus d, that's the negative 86.25. okay, this is equation 2. Now from equation 1, which is velocity at any time t, and equation 2, that's the position or height at any time t, we can answer any questions regarding this path of this flight. Okay, here we are only asked to determine the maximum height. So here is the maximum height. At maximum height, we set the velocity 0, so we get the time, and then we can find this height and we add 40 into that height. So maximum height, we set the velocity 0. For maximum height, we want to find the time first. We set the velocity 0, that's the equation 1, that is 24.5 minus 34.5 e raised to negative 0.4 t equals 0. Now let's solve for t. Solve for t, subtract 24.5 from both sides, we get negative, and divide by this negative, so e raised to negative 0.4 t equals 24.5 divided by 34.5. I just cancel the negatives. Take ln both sides, so ln of this is negative 0.4 t. So t is then ln of this number, whatever that fraction here, divided by negative 0.4, and this is approximately, using calculator, 0.86. So the time is 0.86. So for the 5 kilogram object, it takes 0.86 seconds to get there, the top. Now we can find this height using equation 2, because that's the height function or the position function. Okay, then from equation 2, the height covered in 0.86 seconds, just plug in here. 24.5 times 0.86 plus, here is one more place where we need to plug in, t equals that, it comes out to be very close to 4. In fact, rather -4. -4 makes sense for our purpose because we are saying downward is positive. So this is 4 and this is 40. So the maximum height is 40 plus 4, 44. Okay, so negative is just for orientation. Thus, the max height is 40 already, and then 4, that's the 44 meters final